Let's talk space medicine. I'm Kyle Anderson, your medical student / space nerd host. For your listening entertainment, I gather my other medically inclined space nerd friends to talk all things space medicine. With our powers combined, we hope to explore and entertain the medical questions that stand between us and the stars. Today's orbit, space nutrition, NASA eats, now delivering. As a brief disclaimer, anything discussed on Let's Talk Space Medicine should not be considered medical advice, and is therefore not a substitute for seeking medical help from a doctor. We're simply interested in entertaining topics within the field of space medicine. And today, I'm joined by good old Ryan and Vlad. So excited to talk to you today in Orbit 6 about space nutrition. For the people on YouTube, this is actually the second time we are going through this because I just moved, and I'm going to blame everything that's wrong with this on the move. So hopefully the audio levels are good, and we're really excited today for somewhat of a shorter orbit. Our good friend Vlad here has to go, he's on the wards and doing all, like, saving people's lives and stuff like that. So we're going to try and keep this one short, and really excited to have you all today, where we normally try and complete an orbit within an hour and a half, and that happens to be because the International Space Station, in order to maintain its orbit around the Earth, has to travel around it really fast, and it can make its orbit in about an hour and a half. And so here we have the ESA space station tracker, where we are currently just about to approach mainland Mexico, flying northeast, kind of over the eastern half of the United States. And in an hour and a half, we'll be around the Earth, and we'll be pretty much maybe, looks like southeast of Hawaii and dead center in the middle of the Pacific Ocean. So
right on the equator.
Yeah, exactly. So yeah, that's that, and finally nailed the ISS intro segment, and just really excited to talk about this today. This topic was really Ryan's brainchild, and really excited to hear what we got from our nutrition nerd, and just how we all doing, and what's up.
Doing great.
Yo.
Just gonna have to boot me out of the airlock once you get to the hour mark. I'll make it. I'll make ready for this.
As Vlad has alluded to, due to technical difficulties spanning weeks and scheduling conflicts, you'll have to excuse all of us if we sound a little short in this one, because this is I guess now the third time that we have attempted this episode. The first time we had a critical power failure on a life support system known as Vlad, and we had to reschedule because of that. And then Kyle has the new digs. Problems related to that, of course, caused us to wind up here yet again.
Yeah.
But yeah.
I really liked our first intro. It was good.
Dude,
like,
I was
talking about we
so
talked about
James
James Carpenter films, horror, The Thing. We referenced trying in the future to do kind of like the space news, or like the happenings in space. Where I mentioned TMRO, a YouTube show that kind of goes over everything in space. We mentioned a couple podcasts that I've listened to, talking about expeditions like throughout history that have all like had a through line of nutrition, which is a really interesting point, as well as the world. So that's the Expedition Medicine podcast. So that was that, and then I also talked about the Wilderness Extreme Medicine podcast, or WEMcast, where we talked about some female explorers in the Antarctic having to eat cake in the morning to get the amount of calories that they needed. So that's the quick recap of what I talked about. And you guys can go ahead with what you kind of talked about.
If you guys are watching this as a recording, you missed so much in the live version where it was just me and Vlad talking and laughing at Kyle's silent jokes because his mic was not set up correctly. So
I'm really good at miming.
yeah, I mean, I guess to kind of bring my part, I was definitely probably talking way too much anyway, so that I should be maybe thankful that a lot of that just got cut right out of there. But
No,
for those
no.
for those
Don't
of
say
you
that.
who for those of you who aren't sick of me saying this yet, in addition to me being a medical student, um, currently, I previously did a degree at the University of Michigan in public health, where I did a master's program in nutritional sciences. So, and I coined this term last time. That was my certificate of curiosity, man. I mean,
Yeah. Love it.
that was just off the cuff. That was what a great use of words there. Anyway, I mean, Lord Byron, I'm sure would have been impressed by that one. But
That's a highbrow
other than
reference.
that, so high.
Yeah, the comedy manuals will be
Um,
falling shortly.
um, but yeah, so like I put it to us last time. I should probably just stop that right there since no one's gonna ever know all the cool things we talked about before.
Except for our live
Uh,
audience, which
Basically,
we do these live kind of sporadically.
yes.
But go ahead, Ryan. Sorry for cutting you off. I just got a little excited.
Yeah, so why should anyone care about space nutrition? Certainly, I do. I got a master's degree in it, for crying out loud. Um, but as far as space nutrition goes, nutrition is something interesting enough to get into all on its own. But to me, really the coolest thing about space nutrition as a subject is the idea that when you have all these limitations imposed on you for what you can bring with you into the space environment, especially when we're talking about going to Mars, as we so often do on this podcast, or to a space station floating over Venus somewhere, theoretically in Vlad's head. Uh, you're limited in what you can bring, and food kilogram per calorie is one of those things. Food and water, I should say, is one of those things that it's one of the items that's going to be a problem for per liter. Like, how are we going to get all this there? Because you can grow food on another body, but still, you're gonna need to bring whatever fertilizers, maybe even whatever soils that you're gonna need to grow stuff out of, if soil is needed at all. But you still need to bring all that biomass with you. It's not. I mean, it kind of does grow out of thin air here on Earth, but you still have to bring all the stuff that's going to be made out of in your spaceship, on your space station, or on your base, right? And since we've got all those limitations, we have to think critically about what we know in the field of nutrition right now, and what really is the most important per calorie or per nutrient foods out there that we can bring. And I think that this subject just has a lot of bearing on what we actually eat here on Earth too, right? Because if we find out that this is the optimal way to eat for an astronaut, like maybe I, as a person living on Earth, might start to think about, like, wait, is this, this probably still applies to me as an Earthling. I should probably still be eating all these things that they're getting there, or maybe even more. And that's just a really interesting back and forth. So that's my setup. That'll be my reduced setup.
But
What do you guys think?
But like,
Lay it
wait,
out.
Ryan. But like, wait, 1 second. Isn't like space nutrition like tang and dippin dots? Like, isn't that like what that is? Like, didn't we figure that out? Right?
This is the
Yeah,
scene from
course.
the last Element, where it's just like a pill that turns into like a giant rotisserie chicken.
Yeah. Like, where is that?
I think
Like, that's
Elon's
what
working
space.
on that, but
A dehydrated
before,
Thanksgiving meal in a microwave and you just like slam it in.
I would kill for that, dude. That's what I'm looking forward to.
before we get there, before we get to the meal and a pill, um, there's a number of other things that we can like talk about, right? And Kyle sort of touched on a number of them. There's really two like circumstances uh, besides just the logistics that I've covered. And that's going to be really defined by what kind of nutrition requirements do astronauts need in the short term for things like EVAs, vehicular activities, where they're going out and about on the surface of a planet or on the surface of a space station or some kind of rocket. Um, and we're also talking about what do astronauts need to thrive in their environment on the long term, an order of maybe even years that's going to take for them to get to their destination, set up camp, and build, build whatever they need to build, do whatever they need to do when they get there. So those are kind of the two circumstances that we can touch on, hopefully, in this in this orbit, which is probably going to be more in the order of an hour, just given our time constraints from our last flop. For everyone out there who just loves to hear us talk for as long as they possibly can, I know they're devastated, but for everyone else, they're probably like, yes, they're going to shut up sooner.
This is a short one today.
But yeah, and I have a number of like ways that we can break down these kind of like categories of nutrition related subjects that we can discuss. I know last time we talked about this in our now lost to history recording where Kyle's audio wasn't captured. Kyle, you guys missed out on this great part where we talked about the actual suit that astronauts wear on EVAs. It has like a number of functions that it needs to perform, and one among those is kind of encapsulating the nutrition requirements and just everything related to your GI tract. Kyle, do you want to like touch on that again? I thought that was pretty cool.
Yeah, it was a paper that was published by some people at the Texas A&M University, Go Aggies, Gig 'em, all that stuff. They have a college football field named Kyle Field. So just want to say that I like Texas A&M. And I actually did interview there for medical school. They had an MD-PhD program where they had a bunch of cool stuff going on. Because they're so close to Houston, they actually have a lab called the Health and Human Performance Lab, where they publish a variety of different space medicine work. And one article that came out of there recently that was related to space nutrition was the idea of doing preparing for planetary EVA, so extravehicular activity, but on a planet. So you can do a space walk, which is an EVA in space, or you can do a moonwalk, or you can, I don't know if we're calling Mars walks when astronauts go to Mars, but essentially this this article had talked about the nutrition needs for astronauts performing EVAs on the surface of a planet. And it's interesting because EVAs can probably be looked at. The best analogy is probably either like high intensity rock climbing or like a marathon run. And so for both of those kind of exercises, nutrition, as if anyone is listening does either of those things, you'll know that nutrition is really important to do, to be aware of at least pre-flight or before you do any of these exercises, during and after. You just think of a marathon runner like you having to carb load or having to worry about do marathon runners, like, do they just not pee, or do they just sweating so much that they don't have any volume to pee out? Like I don't know that. I can think about it, but there's a bunch of different things, and so in terms of the astronaut being, the types of foods that they're going to choose are probably high protein, high calorie things. Is that good for them? And then every type of food and liquid, has to be excreted or eliminated somehow. And so, can your suit even handle that? Is what's going to allow for kind of maximum human performance is something that this article talks about. So I thought it was super interesting and somewhat relevant to our orbit today.
I don't know if we've quite gotten to the point like in the Dune series where you've got like complete 100% water reclamation.
A still suit. I want a still suit. It's like
probably just like an IV of like being directed injected directly into the bloodstream or something like that.
What a
So they
cool,
Actually, like
yeah.
parenteral feeding for astronauts is something I hadn't really thought about.
Yeah,
the astronauts, do they have like a little like hamster bottle in there for like sips of water, or are they just like cut off and everything until they come out of the spacewalk?
dude, you know what's crazy? As much as I follow space medicine, everything, as much as we follow it, I don't know. I don't know. I don't think
I think
so.
the answer is
Seriously,
the answer is
Google.
they don't. I think they don't, and I would guess that someone has like considered like, oh, maybe this is like an interesting idea, but it's also like another way that like something can go wrong inside your helmet. And if when that happens, right? Like suppose your water tube just started leaking or something in your helmet, that could be a bad time, and you might have to actually like go back inside to fix it.
There was an
According to
astronaut. Go ahead. Go ahead.
I have an answer here. According to NASA.gov, spacesuits, their little article on spacesuits, apparently the suits do contain water to drink during spacewalks.
Ooh, okay.
That'd be cool to
I'm
look into.
suspecting.
'Cause-
Sophisticated.
Got a little. I'm pretty. It makes total sense for them to have like one of those like runner. Yeah, like those stab sacks or whatever.
They
Well,
just
just
need
think
to
about
fill
it.
one
If
of
you're
those up
parched and
with,
exhausted, you gotta be on your A game. You
Yeah.
can't let
And-
dehydration knock
And
you out.
speaking of, it potentially breaking and causing a problem, I don't know if this is related, but it might be. One astronaut almost did drown in space.
Oh,
There,
that did
there,
happen.
yeah, there was a person that there was some kind of fluid that was building up in their helmet, and they couldn't clear it because microgravity and fluids are kind of like they clump together and they don't stick to surfaces that well, or they stick to surfaces. Surface tension prevails, and it doesn't just fall to the floor, and
Wow.
so you can, if you have water in and around your face, you could like suffocate or drown, I guess. Kind of a different.
Spinning in a circle.
just
Yeah.
drink it all, forehead.
Yeah.
Just kidding. um, but yeah, so man, there's like so many like engineering like little issues and logistical problems that we could dive into, but I want to try to like guide us in the direction back to the actual like foods and stuff.
Let's go for it.
And I think it's important to touch on just the fact that like, and I'll emphasize this. I think Kyle might have mentioned it, but a lot of explorers throughout history, the main make or break of the expedition, the success of the expedition, came down in a lot of cases to whether they brought the right stuff. And you can probably just like look up a Wikipedia article on scurvy if you're like curious about this, but to basically do it, even an expedition on Earth where you're on the water and there are fish in the ocean and like you can get water if you have a way to like distill it or something like that. You can still like have nutritional deficiencies if your trip is on the order of maybe not so much on the order of weeks because it takes usually a little bit longer for like mineral and vitamin deficiencies to kick in than weeks in most cases. But on the order of months to years, definitely you start to see some problems that arise. And Kyle, I think we've also brought up the idea that how just like calories, just getting enough calories on an expedition can be a challenge. Like you said with the cakes that Antarctic expeditioners today would eat for breakfast.
Mm-hmm.
And I think there's been a lot of innovation on this for like explorers in the past. Like they'll eat like really high fat food because a gram of fat has the most calories, I believe 12 per gram out of the or no, is it 9? It's 9. 4,
It's like,
4 and 9, 7 and 9. Yeah.
This is step one. This is a page on step one.
Step
We
one stuff.
we all
Yeah,
are
like carbs,
remembering this
protein,
exact table. That's
yeah,
like
carbs and
right,
protein I
944,
think are
okay.
4 calories per gram. Alcohol I believe is 7, which is interesting.
And then fats was 9. I think.
Yeah, I think a gram of fat is 9. Point is, that's
It's
something
important.
you can exploit if weight is a limitation for you. And I believe things like pemmican, and you can Google this. There's something called pemmican where explorers would basically make like a paste using like lard or butter as like the base. And these are solutions that we've come up in times where maybe we didn't have as many options as we do now. And there's a lot of like cool creative solutions to this in our current day. But beyond that, there are also there's also this crazy subject that we have that we put a lot of stock in nowadays called the psychology. And we found that I didn't actually prepare an article for this. I probably should have, just so it doesn't seem like I'm spitballing this. But nutrition is linked, like, newsflash, nutrition is linked to your mental status, and to have good mental, you need to be eating right. And if you're eating like lard cakes for breakfast every day for a year, it's just not like a great way to
What? You're
get
going to be
people
so
in one
happy
place
for a little bit, probably a little bit of time.
So I guess when you were jokingly bringing up like tang and like dry freeze food and
Yeah.
Dippin' Dots, the food of the future, which I fondly remember back when we were in space camp in fifth grade, Kyle. That was like the thing. It was like, holy crap! Like astronauts have Dippin' Dots. Like it's got to be so cool to be an astronaut. And that for people who've never heard of that or like seen it at like Cedar Point or like wherever they have that stuff nowadays,
Wherever you
it's
feel
like
like you're
it's
being
like a weird ice cream.
wherever you feel like you can buy some food that is definitely overpriced. Like that's where you'll find it.
Yeah, just to like really echo your point though, Ryan, just like that point on expeditions making or breaking based on the resources that you have. Like I'm thinking about Amundsen's race to the South Pole. You know, the first person to get to the South Pole was
Mm-hmm.
between the Norwegians and the Englishmen. The Norwegians got there, made it to the South Pole first, got all the way back. The British came, I think it was, if I see this, they came 5 weeks later and they starved to death. And one of the reasons why this occurred was because the Norwegians really, or Roald Amundsen really, with his team, really thought about how they were going to allocate the resources throughout this North Pole trip. Because, you can't make food in the North Pole. And so one of the techniques that they used was they brought sled dogs that got them all the way to the South Pole. And then they culled half of them and ate the sled dogs. And that was their source of food. And they made sure to eat like the kidneys. They made sure to eat like everything to get all the nutrients that they need to do for the return trip back. Whereas the Englishmen, they thought horses were going to work very, very well. But horses aren't dogs. They need a specific set of food, and they're not going to thrive in these kinds of environments. And they don't provide that kind of nutritional content for the cost as the sled dogs would have done. Which is why you end up having the Norwegians making it to the South Pole first over the Englishmen.
Yeah.
And on,
Go ahead.
and on top of that, like, scurvy killed about 2 million sailors between the periods of Columbus going on his transatlantic voyage, and which is around the 15th century all the way to the 19th century where the first steam engine was made. In fact, financiers of voyages just assumed that half their sailors were going to die on their trips. So that's where it becomes really important. So.
And that was this orbit's Vlad verification facts, in our last recording.
Interject these little historical points that can really get you to really think about what we're facing here. It's not really any different than what we've been doing before. It's just things are getting a little bit more nuanced now. Like when you go to Mars, there's no nitrogen there, so you can't make food. You don't have that problem on Venus, but it's still you have to think about.
Fighting words, oh my god.
So
but,
I don't actually even know if I finished the point I was trying to make. The short version is the short version of it is Kyle. Like, I think a lot of people might also think first of like tang and just like dry freeze food when they think of space exploration, but kind of the shift that I think we see today with NASA and probably other space organizations and NASA's partners is we see a shift towards acknowledging that food plays a role in mental health, and that really the source of the highest quality nutrition comes from whole foods, like an actual apple versus like an apple puree dry freeze, like bag or something, for instance. So tang is not the solution. That's the TLDR of that.
I also think the joke that I made about that was in our previous recording too, but I don't know.
Yeah. But yeah, so I was going to comment earlier, like, when we were talking about the helmets and having like a little hamster water thing, I was going to say like maybe they need to have like one straw for water and the other straw is like soda or something. But at the first time when we originally planned to do this episode, I was hoping to kind of meme and just get a laugh with any of my nutrition friends that might end up watching this one day and like have a Soylent here that I could like show everyone.
Hmm.
Because
Soylent.
dietitians, I think, are very like polarized and probably, I would guess, most of them are against things like Soylent, where we've made an attempt to like simplify the food. Um,
It's made from
'Cause-
people.
yes, I kind of set you up the alley-oop on that one. But
Not actually made
um,
from people. It's a
yeah,
reference to a
if
movie.
anyone is
Yeah.
if anyone is like scratching their head over what Soylent is, it's like a beverage that you can buy that's supposed to be like a meal replacement essentially. And you would drink like you could maybe drink 5 of these a day, and it might perhaps like include like all of your protein requirements, all of your fat requirements, and all the microvitamin or like the vitamins and micronutrients that you would need. And just like one simple ready to go
Hmm.
package or whatever.
So
But
this actually
yeah,
reminds me of something. Is if it's okay for me to interject with something.
please, yeah.
It makes me think of how to store foods and the role of pre or probiotics. So to kind of
This is a huge thing, yeah.
just first set up what those are. So a probiotic is either a compound or an organism or something that or it's actually usually a microorganism, something that normally lines your gut. That is quote unquote a good bacteria that it promotes healthiness or is otherwise associated with well-being. And there are stuff that are bad, the organisms that are bad that can cause disease. And uniquely in the spaceflight environment, the gut microbiome is affected quite significantly. And this is kind of unsurprising because the gut microbiome and the gut in general is one of the fastest turnover tissues of the body. That means the cells in the GI tract are constantly dividing and dying in a normal process. But this also means that they're like kind of uniquely susceptible to radiation. And so the idea of nutrition playing a role in promoting gut health in astronauts is not a new concept, and it's interesting because the storage processes that astronaut food normally goes through, it being either freeze dried or maybe the lack of certain things, are usually lacking these probiotics. And so what my brain said is, oh, what about prebiotics? And so what is a prebiotic? A prebiotic is it is usually a compound that promotes the growth of good bacteria. So it's not yeah, exactly. So it's some kind of it's usually like a fiber type compound, and something that is usually probably better suited to handle these kind of storage conditions, let alone radiation. So prebiotics like promote, it can be a vitamin or mineral, or it could be a fibrous compound, whatever it may be. It's like maybe prebiotics may be the way to go instead of probiotics. But that's what it made me think of
I
with
think
this like meal replacement kind of thing.
I like that you brought this up, and this is something that I hadn't even really thought to bring up, but it's like a huge and very salient like conversation still in the world of nutrition um, here on Earth. But yeah, the way I like to think about it, Kyle, is like probiotics contain actual colonies of bacteria that are thought to be uh, these strains of bacteria that are healthy for us. But whether or not you're taking them, usually your gut's going to be lined with bacteria. Probiotics cause a shift in your gut microbiome, as we call it, from whatever you have just normally, with your normal exposures, towards containing more of what's in the probiotic. And then prebiotics is, to put it simply, it's just the food that your bacteria eats.
Hmm.
Eating prebiotics helps your gut microbiome flourish, and particularly the strains of your gut microbiome that we think are good in related to health. But
So
yeah, that's huge. That's a great like thing to bring up too. Vlad, what were you
yeah,
gonna say?
I just have a question in terms of like prebiotics and probiotics. I know that with diseases like Clostridium difficile, where you just have no, after taking antibiotics, you have no microbes there. Then a baddie takes root, grows, and then you have horrible diarrhea up to the point where you could potentially die. And in that case, fecal transplants kind of
Mhm.
gross, but really important for people who are suffering there because you need to get the bacteria in there to provide enough competition. But aside from that, are there actually any purported health benefits that we actually can make definitive connections with in regarding to have like a quote unquote flourishing microbiome, and what even is, how would you define a
Mm.
flourishing microbiome as opposed from like a microbiome that's been stressed by microgravity?
I have
Dude, I
a
think
comment or
like
two.
these are
Oh.
awesome questions. And hopefully Kyle has the answers because I would tell you that I have a degree in nutrition and I would tell you I don't have the answers. Um, I think there is a body of evidence out there to state like, hey, having this particular strain is related to these positive like signs of a healthy person. And to the extent on what causative evidence like randomized controlled trials and things that like actually show like a dose response curve and stuff like that, I'm not sure exactly where we stand at the moment, and I couldn't maybe tell you. It's been a while since I thought about the exact strains where you're like, hey,
Mhm.
this is the ratio you want of these things. But there also is evidence out there to show that your gut microbiome, these bacteria in your gut can like synthesize neurotransmitters like serotonin, which can
Mhm.
influence your mental health, for instance. And I think there is causative relationships there that have been shown. And I would
And vitamin
imagine,
K as well. Like a
sure,
portion of our vitamin K comes from our microflora.
Mm-hmm.
yeah, that's a great example. And I think you could easily find articles out in the literature. Maybe I'll look like an idiot, but I would hazard a guess that you could easily find articles out in the literature that relate your gut microbiome to like cardiac outcomes and just all sorts of other things, GI health. I mean, all sorts of inflammatory diseases of the GI tract, for instance, are probably connected in there in some way or form. I think there's a lot of like information out there on that. And then adding the like space layer to it is just like insane, right?
Yeah.
Because I'm not sure that like we're maybe starting to get a grip on what a healthy GI tract looks like here on Earth, but I don't even know if we fully understand how the space environment affects the microbiome. But Kyle brings up like a great point, like thinking about playing probiotics is like pretty next level. And
Mhm.
I guarantee you that the Antarctic explorers like are when thinking about that kind of stuff, or just like people traveling, across the ocean.
Oh yeah.
And that's something that we know we need to look out for now, which is awesome.
Yep.
Yeah, this question wasn't to put just you on the spot. Well, it kind of was, but also to get other people who are listening in on these space podcasts, or someone who's like really involved in the literature right now, who's actually contributing to it, some kind of scientist. Maybe we could get a deeper question, deeper exploration from them.
Well, it
Maybe a
is it is
shout out to
interesting
any
you
of them.
say that. This guy, I forgot if it was during this recording or not, but you brought up a YouTube video. I think it was Scott Smith. Is that the speaker? Yeah, I'll just kind of
Yeah.
link to it. So this is I'm pulling up the internet, the YouTube that you link that you gave me, Vlad. But this gentleman here on the right is a NASA scientist, and I believe he has a PhD in biochemistry. And he wrote a paper on bone health and denosumab development that I gave like a seminar to some of the physiology department people. Um, and after the talk, I sent him an email and said, oh, it's really interesting that I used this paper. Could you tell me more about this thing? And he actually responded to me, which was kind
That's
of
awesome.
insane. I forgot what he said, but he was like,
Magical.
he was just like, oh, cool. Like, I just like told him I had given this talk. I was, a naive master's student at that point. So I'm sure he was just like, oh, cool, whatever. Like, but
Nice
anyway,
man.
Yeah, he's a cool guy in my book, and yeah, so hopefully we can talk to him more and see what's up. But I did want to bring up one thing um, that was really interesting that I found. So we're trying to propose all these interesting kind of solutions to this, deep space food challenge. Oh, is there a Twitter account that has that exact same title? There is. And what this group is trying to do, I believe it's NASA funded. They're soliciting kind of new innovations to how to tackle these space nutrition or food problems, and they have a deadline by the end of this month, I think. May 28th, I think, is the deadline. But they pretty much like this link takes you to their challenge, and what do you have to do to win this certain money? Like what kind of project are they, or what kind of specific thing are they trying to tackle? But it's really about supply. How do you get this? Get the food or nutrition to an astronaut? Do you just grow it there? Kind of as Vlad already mentioned in the Antarctic expeditions, like what kind of food can you generate from that? And it's like, oh, well, you have to bring, some sled dogs. But actually, I think in the Arctic, so the North Pole, some explorers, they there was a expedition medicine podcast episode on this as well, where there was a number of different people that were trying to find the Northwest Passage, to get through the Arctic, and the thing that turned the tides, or like broke the ice, or whatever other idiom you want to use that's topical.
Nice.
The thing that the successful expeditioners used, they brought fishing equipment with them instead of more food. So to be self-sustaining, they were able to like kind of have a more successful expedition because they generated the food from there. You didn't have to carry it with you there either, and it's just a much more efficient thing to do. But anyway, they kind of bring up the what foods do you bring, how do you resupply it, and how do you make this successful? And so yeah, there's money behind this if you have a unique and novel way to make good food for happier, healthier humans in space. An initiative in coordination with NASA and the Canadian Space Agency. And so just really kind of interesting. I wanted to bring that up.
Beans and rice, baby. That's all you need.
Kyle,
Beans and rice.
Listen to you talk. The thing, so I'm like sitting here kind of like low key, just like thinking in my head, like, wait, what is like the goal of this podcast? Like I don't know, for some reason I was just having like a out of body experience looking back on us, and I was trying to figure out in my head like what the point of it was. Like what are we hoping to accomplish really? And it occurred to me while you were talking is ultimately the point of this is to like bring up cool things that just like make you want to think about it more. That's and I mentioned this because listening to you talk, I just like feel like I just had like an epiphany of like how this connected with like other orbits that we've discussed in the past, and just like how all this stuff kind of like wraps together. The bit about bringing fishing gear in particular, for instance, and how one kind of interesting solution that is yet to maybe be proven in reality, but has in many cases been talked about in science fiction or just like discussions on what spacefaring civilizations might look in the future, is the idea of growing your food in space. And I can't honestly remember if we brought this up before on this
Attempt
isomer of the show, but
isomer, I don't love it.
I think obviously you still need to bring soil or like nitrogen, as I think Vlad has already said. You need to bring the things that you need to grow plants in order for you to be able to eat them. But like one cool tie-in on this conversation to what things we've discussed previously, at least once or twice, is the idea that like one of the things that you would maybe need to bring is the CO2 that plants need. And I like this a lot this time because I think we've talked about the CO2 scrubber problem before on the ISS currently.
Hmm.
And I don't know if you want to bring this up, Kyle. I did link you a little NASA website on them growing plants and edible vegetables in this apparatus that they call Veggie, which is a really awesome name, and kind of fits in with the cute like planet theme we have going on our podcast here. But
Is
yeah,
this a
I mean,
direct
there's like
message,
potential.
or where is the
Oh, it
link?
was this is in our podcast materials thing.
Oh, okay.
Um,
By the
you could
way,
also
shout out
probably
to
just
our Discord. We have a
yeah,
Discord server where you can sit and chat with us about space medicine stuff all day, all night, whenever you're on, and it's just a nice way to chill, and it's where we kind of do all of our community stuff. So if you want to hop in there and give us a chat, we will love to talk to you.
for sure. And things that we talk about in there will probably be mentioned at some point on this episode or on this podcast. Um, but yeah, I think the growing of food, if it could be done at scale at some point, um, maybe recycling materials like soil could also help solve CO2 scrubber issues in the future, um, which is one of the maybe few things that you wouldn't have to bring with you to grow plants. Here we have a cool picture of a I think this is Veggie. I don't recognize this astronaut dude. This doesn't look like it's even on the space station, judging from like the
Yeah,
giant windows and like clean cut stuff. But
this looks like it's in space.
that looks like Earth.
That's
But yeah,
that flower picture is sick.
that is
Yeah,
pretty
of course
awesome.
Scott Kelly did it, the biggest badass of all the astronauts.
That
But yeah,
guy
I
is
mean,
great.
do we even need soil? Because hydroponics are a
Man, there are some things where you probably like this is beyond nutrition. This is like botany now.
we
I
need to get a
think
botanist.
some to probably get like a diet that includes everything you would need. I would guess that you would need soil for some plants, but you've got this layer of like altered gravity on the plants that I don't know really how the plants deal with that. I mean, they seem to do well from what I've read
That
of the ISS successfully producing like leafy greens, for instance. I think they've done. That's the space station right there.
Yeah, yeah.
Um, and
this has
I
to
think
be
they've,
another orbit in the future, just talking about botany and space, the things
yeah,
that are
man.
available to you. More
But yeah,
support
it all,
for the cloud city because all the carbon dioxide and nitrogen is there. I'm not going to stop this.
You're an animal. You're tearing us
man.
apart, Lisa.
I just hope. I guess my point is like there's a lot of cool overlap in these subjects, and I hope if you took anything away from listening to this, you like thought of how these things tie together and maybe how they affect your actual life here on Earth.
Hmm.
But yeah, I've
For
got like a
sure.
couple other directions like I that I want to steer us if you
Yeah,
guys are okay with that.
you're the
Um,
captain now.
I'm the captain of the expedition, and I just hope that we brought enough orange juice so that we don't get scurvy. Um, but
Spoil some
yeah, I kind
pine
of
needles.
I kind of alluded to the mental health like tie-in. Speaking of tie-ins here, and I think one thing that's interesting to talk about is how astronauts experience food. So in addition to them not being able to eat as much whole foods because having whole foods takes up a lot more room, um, and it's you need this whole machine to like just grow like a couple leafy greens by no means getting to a point where like you're sustaining yourself full time. Even the foods that they do have apparently, and this is another reason why Scott Kelly's really cool in his book. I believe it's called Endurance. I don't remember the tagline, but he talks a little bit about how being a microgravity actually reduces the flavor profile of foods.
Hmm.
And so every like the coin of the land, I guess, lack of land really is spicy spiciness, like
Hmm.
having like anything to add a little bit of picante to your dish was just like crucial, or else everything is just really bland. And so that I mean, eating bland food all the time isn't exciting, is gonna definitely affect your mental. But Kyle actually another cool resource that I sent you was this document that was put together in, I believe, the year 2008, where it's like 150 pages where people tried to characterize the nutrition requirements of astronauts. Um, and buried in there somewhere, I'm not actually sure on the page, but actually, if Kyle kind of scrolls through one of the figures, and this thing has a lot of cool figures. One of the figures in here
Ooh, pretty.
actually tells us that astronauts apparently historically across many missions, and I believe these are a lot of them being short term, some including long term missions, they don't eat as much. And one of the possibilities that we talked before is maybe their schedules get messed up. Like they have a play by play schedule, hour by hour. They're told what to do, and when to do it. And if they mess up an experiment or there's an unforeseen complication, suddenly like lunch might be squeezed out. But I think on the whole, maybe it's the blandness of food or
Hmm.
the the fluid shift in your body, just something about the way things work. It could be even tied to the microbiome changes. I think satiety is something that has been altered.
So I
And
think that's, if you don't mind me interrupting, I think
please,
there's one more factor, and it has to do with the pressurization of the space capsule. So, as many people already know, your ability to taste things is mainly driven, or is a lot driven by smell. And smell, like as people who have gotten COVID that can no longer really smell, the stuff tastes bland. And I think it's like there's some. I think it's a
that's
majority
such
a
a good
majority of
point.
your taste is from smell. I think it's over 50%. Um, but essentially, the partial pressure that you experience on the space station decreases your ability to smell things. Um, it also smells different because it has like this irony metallic scent. I think due to a number of different factors on the space station, and
Mm.
this same phenomenon happens on airlines. So airline food is often oversalted to be like people like it. It's already like typically the stuff of brick walls and comedians of joking about airline food, but airline food, they often have to compensate for this atmospheric change by increasing the salt content. And
Mm.
it actually, I'm just going to do a quick shout out to um, this news article. That was published April 28th, 2021, so not too long ago, titled "How Does Space Change Food Appeal?" And it goes through this
Oh,
exact kind of
sweet segue, Kyle. I love it.
oh yeah, the
That was
sickest of
not planned.
segue, the sickest of segues. Oh yeah, let's go. So yeah, it just talks about kind of habits, what to eat, all this kind of stuff in a really interesting article. And yeah, it just brings up so many questions about, how do you, make it, appear, tasty, flavorful, texture, aroma, all these things that we like know and love, and maybe take for granted. Back to what you said, Ryan. There was a passage in Endurance that talked about Scott Kelly like dreaming of just biting into a cheeseburger off of a grill, and having maybe a slice of watermelon, and just him missing that component of Earth. Like almost every astronaut I've heard speak, for at length or in one of their books, has talked about food as being one of those earthly things that really, they're like, oh, I really miss that.
Mm,
So kind of getting back to the psychology of things also.
for sure. Page 10 on that in that document was the one I was talking about, by the way.
Perfect.
It looks like from the figure, it kind of looks like on average, and this was taken from 55 ISS crew members. If you want to go to page 10 and zoom in there, it looks like they have like a body mass change of about 4%. These have wide error bars, and another thing is I don't
Oh,
know how this accounts for like fluid shift, since it's just straight up mass and like changes to how much fluid you're carrying. But it seems like a real possibility that
well, this is cool.
and this thing itself, this document itself might actually cover it later on with some way of refining it towards food. But yeah,
So
this
can
I
you
mean
walk us through
this
this graph really
document's
quick? Can you just like describe the axes
yeah.
and just walk
So
us through it?
sure. On the left, we've got the body mass percent change from pre-flight, pre-flight being before anyone left Earth. And then on the horizontal axis, you see the FD 130, 31 to 60, and this is just saying like flight day and then this period of time. So FD 1 to 30 would be flight day 1 to flight day 30. And then R plus 0 is return day, and R plus 30 is 30 days after return. So
So
you
so
can
down
kind of
is
see by this
losing,
that the
down is
what's
losing,
up?
and up is gaining. Just
Yeah.
in simple terms, down is losing weight during flight, and up is gaining.
Yeah. I don't actually know how, like, the more I look at this, the more I question, like, whether what it's saying is the same as what I uh, maybe described. But it looks like from pre-flight to flight days 130 is the most drastic change in body mass, being about 4%. And the error bars indicate that it can go beyond that as well. And then it's interesting that at the very end there would be like an
Hmm.
increase. I don't even know. There's no like
Yeah,
indication of what's significant on here. There's
yeah,
only 55 participants in this.
this is the most interesting part.
So
The gap between the last flight days, and the return. Are they like carb loading to try and get back? Like, and or are
that
they?
actually could be a possibility.
Or it could be
There's another.
they're trying to get volume. Like a lot of the times they
Mm,
pre-volume load with water. So this might not actually be like lean mass or something like that. It could just be water.
there's another figure on page 17 that talks about protein intake with a lot of variance, and I think each dot represents, and each dot on that
Space
table
food.
represents a individual astronaut.
Oh, interesting.
So it's, and then I think the recommendation, um, that they say it in the figure legend, the recommendation for protein intake is 1.2 to 1.7 grams per kilogram for high intensity athletes, which they're saying is what astronauts are in this case. And you can see that it looks like they're about, I mean, the distribution seems to be centered at the maybe the lower margin of that. So maybe not all the astronauts are able to get to that amount of intake for protein. And I'm sure that their diet is like heavily manicured too. Like what their options are pre-selected by them or by the administration. I don't think they have to really like think a lot about what they're going to eat on a given day, and like other factors must play
Hmm.
into whether they actually hit their targets.
I know as a kind of an
But
aside,
yeah,
there's a French
I just thought it.
astronaut.
What's up? Say it again.
There's a French astronaut who's requesting French food. For the like every astronaut can actually submit a request to have their like a favorite food, as well as the occasional fresh fruits and veggies that gets sent up on resupply. But I
Hmm.
think he feels like he's being an ambassador to French food for the rest of the astronauts. Because I think every like the I think there's a Japanese astronaut up there who's requesting his own personal food, and it's just all interesting in terms of the everyone's trying to bring their own culture into this international space station. Also, it's kind of cool. It's really part of
That's
our
awesome.
culture, right? It's
That's
part of
cool.
everyone's background.
But yeah, man, I think this document has a lot of like cool stuff. If anyone out there is interested in like digging into it a bit more, it's got a lot of other figures. Kyle might want to check out the section on bone loss and bone
Yeah,
loss countermeasures that they threw in here.
the bones
Which is
are
like on
like
page
the mineral
32.
repository for the body, right? You think of
Hmm.
phosphate, like you just think of bone as an endocrine organ in terms of vitamin D and the importance of that. Like it's there's a
Yeah,
lot of different like mineral metabolism. Like all boneheads are interested in that too. So
to kind of
it's
tie this into other, I think we talked bone and muscle the time before last, the orbit before last, and we did touch on the fact that like astronauts are going to have to solve some of these things through their diet and through activity. And of course, changing your activity also means you need to change your diet. So
Mm-hmm.
there's just a lot of considerations there as far as like what the nutritional needs are going to be for each astronaut, uh, beyond just like culturally, what are they used to eating and like
Mm-hmm.
how is that going to impact their mental. Um, but yeah, we've touched on like a number of really cool things here, and I think we may have accomplished the goal of just like opening up the discussion a little bit. Do you
Mm-hmm.
guys, is there anything else that you guys like really wanted to hit on?
I think
I
there's
mean,
one
it's
thing
just
that's Vlad's. Yeah, go ahead.
just two things I want to hit on. One was like regarding bone health. Like, you can't really suntan space on other planets, right? How
Yeah,
are you supposed to get your vitamin D?
yeah. So
There's
it's
no
super
sun
interesting.
exposure.
Yeah, you're like surrounded in this tin can with like ideally not that many windows, because of radiation and that kind of stuff. And so yeah, your ability to get uh, light exposure for vitamin D is both a psychological factor as many people think of in winter times with seasonal effect disorder, but also in terms of bone health, you're not able to get adequate levels of vitamin D, and therefore calcium regulation's all kind of out of whack. And it's certainly an interesting topic that may change on the surface of a planet. It's like if you're is there going to be a balance between like radiation exposure and like other types of health? Like
Mhm.
activity. Like how much health benefit do you get from just being out in the world, like out exploring a planet, versus the risk of radiation? There might be inherently a kind of trade off that you might have to, oh, I'm really going to balance this person's psychological health versus their radiation kind of counter or their accumulative dose.
I could
Um,
totally imagine, like, I can't remember what cartoon this was, but maybe like a Pixar one where there's like a penguin out in the Antarctic, but it looks like or they're suntanning at the beach, but it's actually just like a UV light with a wallpaper of the Bahamas, and
mm,
outside it's just horribly, like, it's horrible, it's blizzarding, and we're just like,
is it
totally see astronauts. What's that?
claymation or no?
It might be. I don't know. This is like an old memory that I always thought was kind of cozy.
Mm,
Totally, I can
yeah,
totally see cosmonauts having a mental health hour on their busy schedules to
yeah,
just relax and dream of being in some tropical place or wintry
yeah.
place if that's what they prefer.
Mm-hmm. And I think
And yeah,
the other thing that you sent me, if you're ready to transition, I don't know if you were or not,
oh
but
yeah, I am ready to
the
transition
article
into.
that you did send me about iron overload.
Yeah, this conversation has been a lot about we have to ensure that our cosmonauts are getting all the ingredients that they need. But what happens when you get too much? And that's what I kind of wanted to explore a little bit with iron overload. Um, just to touch on it real quick here, with a lot of our with a lot of like astronauts going off into space, we've noticed that they have like increased iron stores for whatever reason. And this is kind of problematic because iron through the Fenton reaction creates reactive oxygen species. Essentially, iron plus peroxide makes reactive oxygen species, and this is really bad for DNA. It's really bad for our cell health. It's really bad just in general. In fact, we might even think that the reason why microgravity causes inflammation, one of the reasons is because of this problem of iron overload, iron buildup. We've noticed that there is a process where the body kills off new red blood cells when we're in microgravity, and this can contribute to an increase in iron. And not only that, but also all of the food that goes to the space station is iron fortified. So we're getting all this extra iron uh, in our kind of like stars in our star peoples that are going into space. And we got to really think about the implications of this in terms of, inflammation, bone health, because muscle health, because these kinds of increased iron stores have been implicated in bone destruction, bone demineralization, as well as our myopathies, our breakdown of muscles. So, I mean, radiation, iron overload, microgravity inflammation. Something else we need to think about when we're deciding on what kind of nutrients that we need. How much is too much when we're going out on our journeys?
Yeah, so my understanding, and correct me if I'm wrong, was that there's like a preponderance for spaceflight anemia, or like a hemolysis that leads to anemia. So this is not really. Is it? Do you perceive this as a elimination problem? So like, are people is it trouble with like eliminating it, like in terms of getting it out of the GI system? Is it just circulating in the blood? Is this causing an actual problem, or like what's kind of your like on the risk factor? Is iron overload like how big of a problem is this? Do you think?
What we've seen in one of the in some of the experiments, evidence from space flights, for example, in that article, it talks about how people who have gone into space and they come back, they've had increase in reactive oxygen species, and we've seen increased iron overload, as well as in kind of ground studies where we've just put people in like upside down positions. They had these increases in these reactive oxygen species, and with in regards to anemia, I think it's just different problems that we all have to face. I don't think it's like one or the other, but just kind of imbalances in our homeostasis, imbalances in our iron homeostasis, as which impacts our redox homeostasis. Do we have the right oxidants and antioxidant balances? And so, I mean, the anemia makes sense, right? Because a lot of the newer blood cells that the body is going through, we have evidence to suggest that these cells end up dying, or for whatever reason, microgravity stimulus, some kind of physiological response.
Mm-hmm.
At the same time, we have kind of like increased iron that ends up building up in our bloodstreams. So it's kind of like both, I think, in that case. I need to look into it a little bit more to kind of more explore how does the anemia, the propensity for anemia in our space travelers, what is that in context with kind of like the iron overload that we see in some of our astronauts?
Yeah, that's so interesting, because part of me, like, as someone who thinks about bone all the time, like the bone marrow, the juicy innards of the bone that I study, is responsible for generating both the immune response as well as the connective the blood system, like a lot of the red blood cells, white blood cells, all the blood cells. And so I'm wondering how much like mechanical stimulus from the bone helps develop like reticulocytes, like these pre-erythroblasts. So these are all different types of red blood cells, which are the cells in the body that look red when you bleed, that carry oxygen, go around in the body and deliver oxygen to all the tissues. But kind of back to Ryan's point, my brain is firing of like, what are the different interactions that could be happening and are really unique to space, and only probably can be studied in space? Because like, in what world can you run an experiment where you have someone who's unloaded, not like having these mechanical forces on the bone, and able to study kind of how the development of these red blood cells actually works. Using gravity as a variable is a very unique situation, and is why the International Space Station is so cool as a laboratory. From the medicine standpoint, like there are people up there, but also a place for those people to perform biological experiments. So kind of both sides of that, yin and yang.
For the nutritional side of things, Kyle, I think you're exactly right too, in that there's not a lot of places out there where you actually have humans whose diets are controlled as much as they probably are to the degree that they are on the space station. Yeah.
And there's a International Space Station food tracker that the astronauts are using, and and it's all curated to the food that gets sent to the space station. And then the astronauts just type in what they ate, how much they ate of it, and then everything auto-populates. I wish we had something like that here.
And it auto-populates, and a little pill comes out, and they add a little water, and they put it in a microwave, and then they're done, right?
I know. They got to start commercializing that kind of stuff. I'm sick and tired of trying to figure out what my nutrition intake is.
I think that actually brings up a funny thing. I think they use a microwave a lot, Kyle, but I think only recently they actually had an oven of some kind brought up that they could use to bake cookies.
Mm-hmm. Yeah, that's right. That's right.
I think they have a way of baking cookies now.
They got an easy bake up there. That's amazing.
Well, it's interesting because it has to work off of induction heating versus convection heating. like the actual heating element has to change because the air doesn't circulate as it normally would. Because hot air doesn't rise,
It's
it's
gonna
not a.
rise, yeah.
I mean,
There's no
I could be getting
gravitational
something
gradient.
wrong, but this is what I was told on like a NASA live, webcast, which they probably dumbed it down for people like me.
Cool. At this point, guys, I feel like we should check our ISS tracker and like see how we're doing. And I also want to check in with both of you on where we're at and whether we feel like there's more to discuss or whether we kind of want to like wrap things up a bit.
Oh, there's always more to discuss. Like I didn't get to touch on how microgravity suppresses erythropoietin production, or why we have the term is called a neo. Hang on, I got to make sure that I get the pronunciation right. The neocytolysis occurs. Why do the young red blood cells die, which results in a 1% decrease of red blood cell mass every day, which connects with the anemia. But then we have this kind of iron overload occurring at the same time. Like, what is going on here in terms of this imbalance and why microgravity is causing it?
Well, obviously, we should consult medicine and see if they're, see if they can get paged up to, the ISS and check on the, hepcidin, ferritin levels, all that kind of stuff. So
yeah, iron studies. And the crazy thing about it too is during that talk, the one that was linked in this chat was the fact that in order, like, there was experiments that were done to track how much urine output and what was the quality of their urine and everything like that. But every time they urinated into like a special sack that then gets jettisoned, recycled, they had to freeze samples in a nitrogen canister, liquid nitrogen canister, and like label it because they're going to be up there for a couple of months, right? You can't just like leave it stored out. Your older samples are going to degrade over time. I'm sure the same thing's happening with blood samples.
Yeah.
And how does freezing blood impact red blood cells? I'm sure there's probably some kind of lysis going on there. It's real cool stuff.
But yeah, to
Anecdotally,
Ryan's.
Kyle. Oh, go ahead, Kyle.
I was just going to say to answer that second part of what you were saying, we're currently over the south of Australia. We are approaching Tasmania, going to fly over New Zealand, say hi to Rocket Lab, and say, hey, better luck, good luck next time. They recently had a launch failure of their small sat launcher. We know that they'll get back to, I'm a big fan. And actually, the CEO of Rocket Lab is a huge Venus fan. So he's trying to send samples to Venus, or send an orbiter to Venus, and he's really a Venusian. But yeah, so we're that's where we are in the world. And yeah, what were you gonna say, Ryan? I'm sorry.
I was just gonna say, anecdotally, I think I heard at a talk that was online that you linked to me, Kyle, from a current space medicine like physician, flight surgeon for NASA. I forget her name, but I think maybe it was her who said that a lot of like what flight surgeons or space medicine physicians do is like actually talking to astronauts about like the quality of their feces and like bowel movements, and that's like a pretty big like day-to-day concern.
Are you talking about the Are you talking about the webinar that we both went to?
I think so. I don't know.
Yeah.
That's just a funny anecdote I heard somewhere. Like, oh, if you plan to get into this field, I hope you enjoy talking about like feces and get your Bristol stool consistency chart out or whatever.
Well, that feels like a like nutrition folks. Like, yes, they're interested on the inputs a lot, like what you put in your body, but they're probably also interested in what comes out of your body too. So,
Yeah.
as the nutrition expert of us, what is that true or?
Yeah, I mean, it really like depends on the concern of the patient, right? Just like anything else. But for people who are having like chronic diarrhea or something, like, yeah, absolutely, that's like a major subject. But yeah, man, I feel like we got to cover a lot of stuff, and hopefully we accomplished the goal that I only just thought of in the middle of our discussion day, just to maybe encourage people to think about it more, and sort of spark some interest in connections between subjects. I think we've done a good job. But yeah, maybe this is like a good time to wrap it up. I think we are actually about an hour from where we first set the ISS tracker.
Hmm.
Hard to know for sure because I think you speed up as you approach the edge of the map.
That's because you're
Just because
going
it's not a
faster,
globe.
right?
The flat earthers might think so, but anyone on a space station will tell you otherwise. But yeah, are we in a good place to call it this time? And maybe at a later date we can revisit anything or just kind of tie back into it with other orbits in the future.
I think so.
Yeah, I think we covered a lot. I mean, just as like I always like to summarize meetings. Like whenever I have a meeting with
Yes.
my lab or like whatever or a patient, it's like, hey, what did we talk about today? And then like they hopefully mentally took notes, and not only it helps them you correct anything wrong, it also reinforces kind of what you said. So we kind of started out space nutrition with kind of laying the groundwork for like the history of it. It's like it's an important thing that has been a part of the history of expeditions throughout history. And what did they do? They ate their own dogs. They tried to bring horses that didn't quite work out. Is what kind of a story that Vlad brought up. Sometimes they have they ventured to bring fishing gear instead of packing more food. They did all these kind of unique things. And expeditions, they had this kind of unique environment where bad stuff did happen, like scurvy and nutritional deficits and all that kind of stuff. We then talked about kind of the sensate, like what does food do for us? How does nutrition affect our psychology? Something that Ryan brought up. And then how does how do you taste food differently in space? How do you how do you sense it differently? And maybe what does it do to us culturally and all that kind of good stuff about food. We then talked about kind of the nuts and bolts, the kind of nutrition, the Bible or the the human adaptation to spaceflight, the role of nutrition, that 151-page document where Ryan kind of went through some nice graphs
I
about
wonder if
how
that's how
protein
they refer
changes.
to it at NASA.
Mm-hmm. Yeah,
It's a food Bible.
your body mass
Tasty
like significantly decreases, like within it seemed like within a couple weeks to a month in space, like it dropped by 6%. That's huge, right? And then it like your ability to actually regain was actually it seemed like pretty quick. I don't remember the graph anymore, but and then what types of foods like are they able to take like are astronauts able to effectively eat enough protein for this high intensity environment they're in. We also reference doing EVAs as this kind of like rock climbing marathon almost, and it being hard to kind of figure out how to train for that, both from a physical standpoint and what exercises you do, but also what you eat beforehand, during, and after. And obviously, as your exercise changes, as Ryan brought up, your nutrition changes, and as your nutrition changes, your exercise changes. So that whole yin and yang. Then Vlad brought up kind of the role of this iron overload and oxidative damage is like kind of a background. It's like we always think of deficiencies like scurvy and vitamin C and other kind of nutrients. But what about overload? Like what happens when through some unknown mechanisms like iron, like these blood cells that have a lot of iron in them are dying early, and the spaceflight anemia, and how do we fix that, and how do we even know what to do? Consult medicine. Consult medicine is always the answer. And so that was just like a really brief overcap off the top of my head, and I would love you all to fill in the blanks if I missed anything.
I think you did a good job. I want to applaud Vlad for sneaking in some actual like piece of academic literature in there. I think that's probably one example of like 1,000 interesting things going on.
Mm-hmm.
But at least one cool thing that has been going on recently in the space medicine research world. Yeah, guys, I think we did a good job. It took us 3 times to nail it, flesh it out, but I think we hit it.
Let's just hope the heat shield helps us with re-entry.
Yeah, you can't redo that one. Although, yeah.
Here we go.
All right. Well, thanks for joining us, everyone and our listeners on YouTube. Join us in the Discord. Just want to say thanks for listening to Let's Talk Space and Medicine. If you want to continue the discussion and meet more fellow space nerds, be sure to check out @TalkSpaceMed on Twitter and the Let's Talk Space Medicine server on Discord. Thanks, and see you next orbit.